A curve has the equation y is equal to 2x power 3 minus 9x power 2 plus 12x plus 8. Find the coordinates of the stationary points of the curve. That's the first question. So basically, what we're going to do here is to copy the given equation, which is a y is equal to 2x power 3 minus 9x power 2 plus 12x plus 8. So this is a given equation. And once we get this given equation, we find the dy dx. Find the derivative of this. So in case you don't know, let me just run you through a little bit on how to find the derivative. So to find the derivative of any given equation, let's say you've been given y is equal to a power n. So to find the derivative of this y equal to a power n, you're going to say dy dx is equal to, you get this power, you multiply it by the number that is in front, so it will be n a power n minus 1. Look at this. There is a 1 here, so you multiply this times this, you get n, you maintain the a, to the power you subtract a 1. This is what you need to do for you to find the derivative. So let's try to find now the derivative. We said you multiply this power by the coefficient, it's giving us a 6, x power 2. When you subtract 1 from the power, so it will be 3 minus 1, it will give us a 2. Minus 18, that is 2 times negative 9, it's negative 18. You shall have x power 1 when you subtract a 1 from this. And for this, it will just be a 12. Okay, so I'm not going to talk about this in details, why this is a 12. But all what you need to keep in your mind is that there is a power 1 here, so you multiply this 1 times 12, it will give us a 12. You subtract a 1, it will be power 0. So x to the power 0 will give us a 1. 1 times 12, it's a 12. For the constant, derivative of the constant is a 0, so ignore the constant. Therefore, we can say our dy dx is equal to 6x power 2 minus 18x plus a 12. This is a derivative. Now the question wants us to find the stationary points. For the stationary points to be found, you're going to say 6x power 2 minus 18x plus a 12, say equal to 0. So just get this derivative equated to 0 and solve this quadratic equation. I'm going to reduce it throughout by 6 so that I can remain with x power 2 minus 3x plus a 2 is equal to a 0. Now in solving this quadratic equation, I'll write x inside the brackets, and also here x is equal to 0. Think of two numbers, when you multiply them, they give you negative 2, and when you add those same two numbers, they give you negative 3. It's a negative 1 and a negative 2. So we can say x minus 1 is equal to 0, or x minus 2 is also equal to 0. Therefore, we can say x is equal to a 1. Okay, you solve x is equal to 1, or x is equal to a 2. So these are the two x values at the turning point. Y is equal to 2x power 3 minus 9x power 2 plus a 12x plus 8. Now, we find the y values, meaning we're going to get this x value, we substitute where x is here. So it will be y is equal to 2, 1 power 3 plus 9, 1 power 2 plus 12, 1 there plus 8. So when we simplify, what are we getting? A 13. So when we simplify, the y value is 13. So we can say one of the turning points is 1, 13. Okay. So for the other one, we do the same. We get this 2, we substitute here, here. So when we substitute, it will be 2 here, 2 power 3 minus 9, 2 power 2 plus 12, 2 plus 8. This, of course, is giving us a 12. So the other turning point is a 2, 12. So these are the two turning points of this curve. We now go to the next question and see what we're supposed to do on the next question. So what we're going to do here, we'll go back to this stage. Okay, hopefully you can remember this stage. I've put it in the box. When we are solving this part, we get it and it will be like this. Okay, can you see? We'll write that stage at this point. And then you can see that here I've written slightly less than 1. So you get any number less than 1, try to substitute it in here. For example, I'll get a 1.5. Put a 1.5 here and then work out. It will give you a negative value. Even here, it will give you a negative value. And when you multiply negative by negative, we're getting a positive. So meaning it's coming from down here to the from negative to the positive. It's moving like this. You get this, substitute, you're getting a 0 here. So here, this is where there is a stationary point. You get a number greater than slightly, it's supposed to be slightly greater than 1. So get maybe 1.1, put it here, you're getting a positive value. And when you put it here, you work out, you're getting a negative value. When you multiply this positive by negative, you're getting a negative. So it's dropping this side, okay? So this shows that at this point, the stationary is like this. The curve is like this. And the point is right over somewhere here. So this implies that we've got a maximum point at x is equal to a 1. So maximum point at x is equal to 1. So we're done with 1 point. We know that it's maximum. X is equal to 1 is maximum. Now let's try the next one, which is x is equal to a 2. So for x is equal to 2, the same procedure, okay, the same method. You get a number slightly less than 2. So less than a 2. That will be maybe even a negative 1 point, a 1. We can even get a 1.5. So 1.5 here, we're getting a positive. Here 1.5, we're getting a negative. So this side, we're getting a negative. Here it will be a 0. So the graph is dropping like this from positive to negative. Here it's a turning point. That's where a stationary point is. So it will be equal to 0. We get a number slightly greater than a 2. So maybe 2.5. You put it here, you're getting a positive. You put it here, you're getting a positive. So here it will be a positive. So here it will be like this. Okay? So meaning the graph is coming from top all the way, it turns and then it goes like that. So meaning here it's minimum. Minimum point. Minimum point at x is equal to a 2. So that's how you get to answer this. Let's check out the next question. All right, so for the last question here, which is question B, we need to find the coordinates of the point where the curve, this and this, where they meet. In order for us to find where they meet, we are going to get these given curves. And once we get them, we equate. So this is x over 2 minus 3 is equal to e power 7 plus 3x. So I'm equating because here it's y and y here. So meaning this and this are equal to each other. And this is what I've shown. From this point, we can use the property of bases. When the bases are equal to each other, we equate the powers. And this is what we are getting. We can now multiply throughout by a 2. This denominator, I don't want to have a denominator or a fraction. So I can multiply. This will give me a 2x minus 6 is equal to 14 plus 6x. We now group the like terms. 2x minus 6x is equal to 14 plus 6. Negative 5x is equal to 20. Divide by negative 5 by negative 5. So the value of x will simply be equal to negative 4. So that's the value of x at the meeting point. So once you get that value of x, you can now find the value of y, get on any of the equations. If you want, you can get the first one. So let me get the first one, which is y is equal to e power x over 2 minus 3. So where there is x, you substitute the value of x, which is a negative 4, and then you've got over 2 minus 3. Here it will be e power negative 2 minus 3. Don't mind this, minus 3. So this is simply giving us e power negative 5 here. So the point is negative 4 comma e power negative 5, like that. So now finding the gradient at this point, because they said we also find the gradient of each. So finding a gradient at that point, we just get these given curves. So the first one here is y is equal to e power x over 2 minus 3, and then we say dy dx is equal to, the derivative of this will simply be equal to 1 over 2e power x over 2 minus 3. This is a derivative. So we are going to say m, which is a gradient, is equal to 1 over 2e, and then here we substitute negative 4. The value of x, which is a negative 4 minus 3 here, this is giving us this. So this is the gradient, okay, for this curve. The other curve, we've got y is equal to e power 7 plus 3x. We said dy dx is equal to, this will be 3e power 7 plus 3x, which is equal to 3e 7 plus 3. We substitute a negative 4 here. So this will be 3e 7 minus 12, which is equal to 3e power negative 5. This is the other gradient. Thank you for watching. Please, if you want more help in additional mathematics, this is the number you can WhatsApp us. We will add you to our online classes. Thank you and bye-bye.